Hi, everyone. Thank you so much for joining us today for Intro to HoloLens 2 development using the Unreal Engine and MRTK Unreal. We are going to show a brief recording today. Carl has gone ahead and pre-recorded some information for you, so we are going to show that, and then Carl will join us at the end to take your questions live. Before we get started, I have a few quick things to go over. Please take a moment to read over our code of conduct. We ask that you be kind and respectful to everybody, including our speaker. We want the reactors to be somewhere that everyone feels welcome. Please feel free to use the YouTube chat to ask your questions. You're welcome to ask questions at any time. And then we will be sharing some links in the chat as well. We'll have links to our Reactor Meetup page and newsletter if you're interested in signing up for either of those to see what other sessions we have coming up. We'll be recording this session and it will be on our Reactor YouTube page in 24 to 48 hours. If you have not done so already, please check in for today's events. You will receive content that goes along with today's session. You can check in at aka.ms/reactor check-in with event ID 14454. I have shared that in the YouTube chat and I will share it again here momentarily. And then finally, towards the end of the session, we will share a link to our Reactor survey. If you have a few minutes, we greatly appreciate your feedback. I am now going to start the recording, and then once that is over, I will bring Carl on and he will answer your questions. Thank you again for joining us today.
Hello everyone, I'm Carl, and today I'll be giving you an overview of the end-to-end flow of building a simple app for the HoloLens 2 using the Unreal Engine and the Mixed Reality Toolkit for Unreal. This talk is aimed at people with a basic knowledge of the Unreal Engine and are interested in getting started with the Mixed Reality Toolkit. The Mixed Reality Toolkit is a set of plugins, samples, and documentation that simplify mixed reality app development. It currently consists of 2 plugins, UX Tools and Graphics Tools. UX Tools contains a set of actors and components to help build and test interactive environments. It includes various UI elements like buttons and sliders, and also in-editor input simulation system that allows you to test your app without having to leave the editor window. Graphics Tools is a set of building blocks for increasing the visual fidelity of your scenes while staying inside the performance budget of the HoloLens 2. It has a simplified physically based lighting model, various optimized graphics effects, and a visual profiler you can place in your scenes to monitor their performance. We won't be diving into the specifics of these plugins today. We will be using them to create a simple interactive level, but our focus is on the end-to-end flow of project setup, creating a simple interactive scene, testing an editor, testing remotely on device, and finally building a package we can deploy to the HoloLens 2. I won't be showing the development environment setup today either. This is a straightforward checklist of ensuring you have the right Visual Studio workloads installed, and if you have a HoloLens 2 headset, putting it in developer mode. If you're following along today, you will also want to install a Holographic Remoting player onto the headset so we can remotely test our scene on the device, and download the chess assets from the Mixed Reality Unreal Samples repo, as they're what we'll be using today. And with that, let's jump out of PowerPoint and over to Unreal. We'll start in the Unreal Engine Marketplace as we want to get a few plugins for our project. The plugins we're looking for are tagged with HoloLens, so we can use that as a search term to find them. We want to download the Mixed Reality Toolkit Hub and the Microsoft OpenXR plugins. The MRTK Hub is an entry point to the MRTK, and we'll be using it to install UX tools and graphics tools into our project. And the Microsoft OpenXR plugin will give us access to holographic remoting for testing our changes. Once we have those installed, we can go ahead and launch the engine. We'll be using Unreal Engine 4.27 today. We want to make a new blank project. And we want to set this project as a blueprint project, as we won't be using C++ today. We also want to set it for scalable 3D and 2D and for mobile and tablet platforms. And we can just go ahead and call our project chess game. Now that our project has loaded, we can go ahead and open the plugins menu. And go to Mixed Reality and enable the Microsoft OpenXR plugin and Mixed Reality Toolkit Hub plugins that we just installed. And we'll be prompted to restart the editor. After the editor has restarted, we can close the plugins menu. And we can open up the MRTK Hub through the toolbar button. Here we can select that we want to add the UX Tools and Graphics Tools plugins into our project. We don't need the examples plugins for this demo, but they're a great resource for learning how to use the different parts of UX Tools and Graphics Tools. I'll fast forward through these installs as they can take some time, and I'll join you back when we're ready to start creating our scene. Next up, we want to import the assets that we downloaded from the samples repo. I've just got them in a folder here called Assets, and I'm going to copy that directly into our project's content folder. Unreal has detected that we've added some new assets, so we can just use the prompt to import them. We do want to make some changes to the models we're importing. They're quite large, so we want to scale them down to about 0.05. And we also want to set it to not create materials for them, as we're going to want to create our own materials using the Graphics Tools lighting model. These settings don't change between models, so we can just import them all. Once the import is completed, we can go to our content browser and open up the assets folder, and now we can create some materials. So I'm going to create the board material as the base material and then create instances of it for the piece materials. So we can go ahead and call our material mChessboard. And the first thing we're going to want to do here is change our shading model from default lit to unlit to disable Unreal's lighting model. Now in our graph, we're going to want to search for GT to bring up the graphics tools options. And we can see a bunch of material functions available to us, but the one we're interested in is GT default lit, which is the graphics tools PBR lighting model. And we can hook this up to the emissive color of our material. And from here, we can start adding our texture samples as you would for any other material. So we're going to start with a texture sample for our albedo or our base color. And then for our metallic map, our roughness map, our normal map, and finally our ambient occlusion. These can be hooked up in almost the same way as the standard Unreal lighting model. The only difference to take note of is that the normal entry on the default lit material function asks for the normals in world space. So we need to transform our normals into world space before we pass it in, but the transform vector node's default settings will do this for us nicely. And finally, to use this as a base material, we're going to want to convert our different texture samples into parameters so we can override them in our piece materials. And now that our material is ready, we can save it and go back to our content browser, create a new material instance from it. We can create our black material. And here we can override the parameters with the corresponding textures for our black material. And then we can do the same thing again for our white material. Next up, we're going to start creating our demo scene. So we can go back to the root of our content browser and create a new level. And we can call it chess game. And open it up. We're going to want to slow down our camera and reduce its speed to 1. This is because our models can be quite small and the camera will move far too fast when it's on speed 4. We're going to skip creating blueprints for our actors for this demo. So we're just going to go back to our assets folder and drag the chessboard model straight into our scene. We can zero out its position and then set its material to the board material we just created. You can see it looks quite dark, and that's because we don't have any lights in the scene. But instead of going and adding some Unreal directional lights to our scene, we're going to want to search for GT to find the GT directional light actor. And when we add one of these actors to our scene, that'll get picked up by the graphics tool's lighting model and light up our board. We can move the light just above our models. And we can also turn down its intensity because it's quite bright at the moment. Somewhere about 3, I think looks good. We can also rotate the board so that it's facing us. And now we can see that our board is lit and looks great. So next we can add a piece to our scene. We'll pick the knight. And we can also set its material. We also want to make sure our knight is set to movable, as this is going to be the interactive part of our demo. And finally, we'll add a player start to our scene so that way we have a consistent start location. Now that we have our scene ready, we can go ahead and start setting up our game mode. This is going to consist of 3 pieces, an Aor Session Config, a pawn, and then the game mode itself. So we can start by going back to the root of the content browser. I'll create a new folder to hold this. We'll just call it game mode. And then we can add an Aor Session Config by going to add miscellaneous data asset and Aor Session Config. And we can just name it Aor Session Config. So we can just open this and save it with the default settings, but this is where you would configure things like generating mesh data for the world surrounding the user. Next, we'll create our pawn, which we can do through add blueprint class. We want a default pawn instead of the base pawn, so we can expand the all classes and search for default pawn. and select that and name it MRPawn. There's a few changes we want to make to our pawn. The first one is disabling collision on its collision and mesh components, because we don't want our player's headset to be colliding with things in the world and getting stuck. We just want it to pass straight through so that their in-game camera always matches their real head position. We're also going to want to set up our hand tracking now by going to our event graph and on begin play spawning some UXT hand interaction actors, which are the UXT component that will track the player's hands in the world and use that to drive interactions with UXT, UI, and components. So we can do this using the spawn actor from class node and setting this to the UXT hand interaction actor. We're going to want two of these, one for the left hand and one for the right hand. We can hook these up to a sequence node just to keep it nice and clean. We'll also need to give them a transform. This transform doesn't matter as the hands are going to move with your player's hands anyway. And we also need to give them an owner, which we can just set to a reference to ourselves. And now we can just clean this up a bit. And that is our pawn ready to go. Now we will create our game mode, which you can do through add new blueprint class. And this time we can just use the base game mode and call it MR game mode. In the game mode, we're going to want to set our default pawn to the MR pawn we just created. And we're also going to want to go to the event graph, because in our game mode, we're going to want to start and stop an Aor session with begin and end play. So we can do this by just dragging off and adding a start Aor session node, which we will pass the Aor Session Config we just created earlier. And then we can add an end play event and connect that to stop Aor session. Now we can set our game mode as the default for the project by going to our project settings, maps and modes, and setting our default game mode to our MR game mode. And while we're here, we can also set our chess game level as our default startup level for the editor and game. Now we can test out our level by using play and editor. We can see our UX tools input simulation hands here. They can be controlled by either holding Shift or Alt for the left and right hand. And then while holding one of those buttons, you can move the mouse to move it, left click to select, and right click to rotate. We also see we have an error on screen as we are trying to start an Aor session and the play and editor session is not on an Aor device. So we can remove that error by going back to our game mode. And before starting and stopping our Aor session, we can do a check for is Aor supported. And then only enabling and disabling the Aor session when we are in an Aor environment. So if we save this and run our play and editor again, we'll see the error goes away. Now our scene looks great, but it doesn't actually do anything yet. So to fix this, we can go ahead and select our knight and add a UXT generic manipulator component to it. This is all we need to do to make the knight visible to the UXT hand tracking. So if we go to our play and editor mode now, we can reach out with our input simulation hands and pick up the knight. But as you can see, as we drop it, it doesn't actually fall back down to the ground. So we can make it do this by selecting the knight's static mesh and setting simulate physics on it. So now, if we go back and we pick up the knight, it will drop back down as we expect. The UX Tools generic manipulator is detecting that the mesh has physics enabled and is disabling it when we pick it up, and then we'll re-enable it when we let go. Now that we have an interactive scene, we can test it on the HoloLens using Holographic Remoting. We can enable Holographic Remoting by going to our project settings, and we want to first set Start in VR to True, and then we want to scroll down to our Windows Mixed Reality platform settings, and here we have our OpenXR Holographic Remoting settings. So we can enable this when we're prompted to restart our editor. While the editor is restarting, we can go to our HoloLens and start up the Holographic Remoting player. Once this starts, we'll be presented with an IP address, and this is the IP address we want to use to connect to from within the Unreal editor. So we can set this IP here in this field. And we also want to set it to automatically connect. So this way, when we start the VR preview, it will automatically connect to our remoting player so we can preview our level in the headset. Now, if we go to the drop-down menu beside the play button and select VR preview, we will start our holographic remoting session. And now we can test the level as if it's running on the device. The perspective looks a bit off because we're only capturing one eye's view, so it looks like my hand is behind the board. And once we're happy that our level is doing what we want to when working with a real device, we can go and now start setting up a package that we can deploy and run natively on the HoloLens. There are a few more things we need to change in our project settings before we can actually create our package. So if we open up our settings page, we're going to need to give our project a name. We'll just call ours Chess Game. And we're also going to need to give our publisher a distinguished name. This is for the self-signed cert we're going to be creating to sign the package. Next, if we go down to our HoloLens platform settings, this is where we would select if we want to build for the device or for emulation. We can also configure our start menu tile here. And what we need to do is generate a new self-signed certificate. We can just give it no password as this is just for testing. And the last thing we need to do is go back up to our supported platforms and enable HoloLens as a supported platform. Now we can go into File, Package Project, and select HoloLens. I'm just going to drop our package into the root of our project. And I will join you back when the compile has completed. All right, so now that we have our package ready, we can sideload it onto the HoloLens through the device portal. We can connect to the device portal by opening our browser and going to the same IP address that we connected to for holographic remoting. We can log into our HoloLens. Then once it opens, we can go to Views and Apps. And then under Deploy Apps, we can select Choose File, navigate to where we generated our package, and select chessgame.apexbundle. We also want to set Allow Me to select optional packages. And we want to choose the VC libs that were generated alongside our package. Now we can hit install. And once the install finishes, I will come back on the HoloLens to demo our running game. Once the deployment is completed, we can find our game under the All Apps section of the Start menu. It might take an extra second to load the first time. But here we can see everything as we would expect. It does look very choppy because we are both running and recording off of the HoloLens. But if I was to stop the recording, this would be running as smoothly as it did in the editor and in Holographic Remoting. And that just about wraps us up. I hope you learned something today. On screen are some links to relevant documentation if you want to learn more about UX tools, graphics tools, and OpenXR on the HoloLens 2. Thanks for coming, and I hope you all have a great day.
All right, hello everyone. I haven't seen any questions in the chat so far.
While we're waiting to see if a few questions come in, is there anything else about this topic that you would like to share or that you think would be helpful for folks?
Yeah, we do have other talks. Some are, there was an Inside Unreal presentation and another, I think it was an MWare Dev Days recording, which I can get links to and send to you to put in the resources for today's session. And I'll also put together any of the links that were in that video just to make them easier access. We also have a written tutorial that goes through a similar chess game. It's slightly older, so it doesn't include the MRTK Hub or graphics tools, but it can also be a good resource if you prefer looking at written content instead of videos. Because I know, at least for myself, sometimes if you're trying to learn one thing and there's a video and you're skipping around trying to find the bit you care about.
Definitely. And do you have the link for that one? Because we do have one question where they say, can you provide me a link to get started with Unreal and MRTK? Is that the intro to
Yes.
MRTK for Unreal?
Yep, I posted it in our chat there.
Perfect. Share that in the comments. It looks like we have a few questions coming in.
Yeah, so is there a way to make a 3D chat app in HoloLens with this toolkit? Yes, there is. There isn't networking built into it, but so it's currently still in a beta release. Network synchronization for things will be something that is on the roadmap for kind of the V1 or later releases. And there are other built-in things into Unreal or other plugins you can then use for audio and those kind of things. So it'd definitely be possible to use this to help you build 3D chat apps. I have another question of what would you say is the advantage of using Unreal instead of Unity for HoloLens development? If you prefer Unreal, that would be a big one. Unity is definitely a much more tested and kind of older, there's more resources around it. So if you are familiar with Unity, and Unity is definitely the more mature toolkit with the MRTK for Unity. But Unreal only got HoloLens support last year, so we've only been working on it for just a little over a year. And we hope to bring it up to par with the kind of level of tooling that exists for Unity. And I think that also covers how is it different from Unity 3D? How can we create custom models and applications with new 3D models? So you would, in terms of different Unity 3D, it's newer. And you would import your custom models the same way you would any other model for Unity or Unreal, where you could build them out in 3ds Max, Maya, whatever your Blender, the modeling application of choice, and export it as an FBX or any other format, import it into Unreal and put it in. You do just need to be careful that they can't be too detailed, as the HoloLens isn't the fastest at rendering high detailed models. Things like graphics tools do help, where it can help you simplify your materials and lighting calculations. But if you have a really high detail model, the HoloLens will struggle. But if you do need to display extremely high detail things, you can build apps kind of focused on holographic remoting, where you are only ever streaming your game to the HoloLens. A good example of that is the recent the Epic release, I think, very recently. Was it called Mission Aor? Mission Aor? Project Anywhere XOR, which is a primarily remoting-based application for 3D geospatial visualization. I've dropped dropped the link in our chat there if you want to share it. And so there's plenty of different things you can use for building out your apps. Next question, is there a technological overlap with XOR LED production, which also uses the Unreal Engine? Can you use assets in both environments? I don't actually know. Yeah, sorry. I'm sure I can find an answer and get back to you at some point if there's a way of doing that. But I would imagine a lot of the kind of production level things that would be done would probably be too intense to run directly on a HoloLens. And next question, is there a difference in performance-wise compared to Unity? I believe Unity might have a small performance edge just because it's more mature, more time spent optimizing, but I don't know for sure. And from the examples we've had internally where we've had the same app built in both, the performance has been pretty comparable. So I don't see any more questions. So if none come in the next couple of minutes, I think we're... All right. Do I need a HoloLens 2 or is there a virtual HoloLens solution? There is a HoloLens emulator that you can install onto your machine. You just need to have virtualization enabled, and that is free, and you can download it, install it, and it gives you another form of input simulation with articulated hands that you can use to test out your HoloLens apps without actually needing a HoloLens device.
All right. Well, while we're waiting to see if a few more questions come in, I just want to say thank you, Carl, for joining us today. This was an amazing session. Lots of great feedback in the comments and people who really enjoyed it. So thank you so much. And thank you, everyone, for joining us. I have shared some links in the YouTube chat. There's some links to the Reactor Meetup page and newsletter if you're interested in signing up for either of those to see what other upcoming sessions we have. I've also put a link to our survey. We do really appreciate your feedback. It helps us figure out what other content we want to put on. I will share that link again, just in case it's gotten lost in with all of the great questions. So yeah, it looks like it's that's it for questions. Again, Carl, thank you so much. Hopefully we can have you back again soon. And thank you, everyone, for joining us. And hopefully we will see you all soon for another session.
Thank you for having me.
Bye, everyone.